What's up, guys? It's Brent with Lykins Motorsports. Happy Friday morning to you guys. Um, if you've been a subscriber of the channel or maybe just seen it on various social media platforms, Instagram, Facebook, that sort of thing, several weeks ago, I was able to dyno a Ford FE that made 894 horsepower. So basically cracking on 900 horsepower while turning the accessories, the water pump, alternator, and that engine used J. Brown's FE power cylinder heads and intake manifold and rocker arm setup. Just a get it out of the box, do the normal machine work type of deal. And I've done two engines like that so far. One of them has not been dynoed, and one of them we were able to complete. So mine was, I think, the second one that was able to be dynoed. Jay had his own dyno mule that he built to test his parts on, and that engine was dynoed a year or two ago. So I was able to get this one out. Was really pleased with the results. 510 or 11 cubic inches, 894 horsepower. Again, turning the accessories, and we were fighting a Canton rear sump oil pan that just proves time and time again to be a pain in the hind end on the dyno. So I think in perfect circumstances, I always try to dyno the way that the engine will be used in the vehicle. So in this particular application, it's a street engine, okay? So it would be turning a water pump and an alternator and using that oil pan. So in a perfect situation where we had a nice front sump oil pan or a really deep flat bottom pan, electric water pump, no alternator or everything like that, I think we could have hit maybe around 915, maybe something like that. So again, really nice parts out of the box in terms of making horsepower, and you just don't really see a lot of FEs making that kind of horsepower, and that's just due to various variables, the head design and that sort of thing. We could get into that at a later date, but all of that kind of got my blood pumping on doing another one and doing maybe kind of like a max effort type build. So called one of my customers, Mr. Dennis, and he buys a lot of camshafts and cylinder heads and rotating assemblies and stuff from me. And I was like, what do you think about giving this a shot and trying to see how far above the 1,000 horsepower mark we can make, and if we can hit that 2 horsepower per cubic inch, or maybe just a little bit higher number. And he was like, "Yeah, I'd like to try that." So we started bouncing ideas off of each other and going through what the build would consist of, and there's a few variables that we haven't knocked down yet, because he went ahead and bought a pair of heads from Jay, and I ordered a set of custom titanium Ferrea intake and exhaust valves. So Jay is going to have the guy that ported the heads for my last build do those heads and see if he can improve on those a little bit more. So the last heads flowed, oh my goodness, I have so much many numbers rattling around in my head from time to time. Somewhere around 440 CFM. We're trying to see if we can get somewhere around 480 if we can. And I'm waiting to see what the heads finish up as, and before I make any decisions on displacement and that, the rest of the variables that we don't have. So there are some 1,000 horsepower FEs floating around, and I know Jim Kuntz, either Jim before he passed away, or the current guys that own the shop have a couple. From what I've heard, somewhere around 1,003 to 1,012 horsepower with a 505 cubic inch motor. So that's right there at that 2 horsepower per cubic inch mark. They also had a little bit bigger engine that made 1,100, but with billet heads. So in terms of cylinder heads, FE cylinder heads, we have, the old factory style cylinder heads, low riser, medium riser, tunnel port, high riser, camera. We have new FE heads, so Edelbrock, Blue Thunder, which are not made anymore, Trick Flow, and there's various flavors of new tunnel port aluminum heads out there, and then of course J. Brown's heads. And then we have the billet heads. So there are a couple of, I think there's 2 manufacturers of billet Ford FE heads. I wouldn't, in my personal opinion, I don't consider those FE heads, because when I think of a FE, I think of the intake manifold making up half of the valve cover flange. Uses an FE valve cover. The billet heads kind of look like a big block Ford, big block Chevrolet cylinder head, and it's completely different design. I think some of them have cannon valves. So I kind of write that off. I kind of write off the camera heads that make 1,000 horsepower. So what we're doing is we're going for as much horsepower as we can make, and my personal goal is the highest horsepower per cubic inch that we can make with the newer style true FE design cylinder heads. So we're going to use Jay's heads. We're probably going to go with a full sheet metal intake design, pop a couple of big dominators on it. Already got a block. I'm going to show you the block here in a second. But we're going to go for broke and see what we can do. I have my own goals. Mr. Dennis has his own goals, but we'll see what we can come up with. I think we can hit 1,000, and that's not a problem. And I would like to hit 1,000 with Jay's heads, just to show what we can get with what he has designed and put out there, with some port work and with some specialized parts. Definitely going dry sump. Definitely going high compression ratio, going to spin the poop out of it. So, we're going for max effort here. Let's talk about engine blocks. So when Dennis and I were talking about what kind of block we were going to use, we're looking at Pond, we're looking at Shelby, and we have decisions to make there. Dennis already had several BBM blocks that he had bought several years ago, and I would rather see a Pond if we were doing cast iron, but I'm not going to ask somebody to spend another $5,000 on a block when he has several sitting there. So we will get this one checked out and fight through some of the issues that I've seen in the past. He also had a Shelby block, but the issue with the Shelby block, although it's a very nice block, it is aluminum. Aluminum blocks give up horsepower. So when we're going for a max effort type deal, some of these aluminum blocks can give up, you know, 3, 4, 5% in terms of horsepower, and we don't want to lose that kind of horsepower. Even if we lost 20 horsepower, you know, we don't want to do that. So definitely cast iron. So we've got a BBM block, and yeah, so we're just gonna press along, and I'm gonna drop this thing off at the machinist's shop next week and start the process. I've got a long list of stuff that needs to be done. We're gonna run lifter bore bushings. We're gonna run roller cam bearings, and you know, have all the normal board honed with torque plates, line hone the mains, square the decks, all that sort of stuff. So we've got some groundwork going on, and we'll just make progress. I'll report back to you guys each time that you know, we have an update, and we're going to see what we can do. So I'm going to show you the block now. We're going to go over some stuff with the BBM block, and we'll continue on. All right, so this is Dennis's BBM block that he sent me. I picked it up yesterday. This is one of their newer blocks. So the old blocks had a gray coating on those. I didn't really care for the gray coating. It seemed to flake off easily. And what I normally do, if somebody sends in a BBM block that's got the gray coating and everything in it, I usually go ahead and have those blocks baked and tumbled. The black seems not to come off. I generally do not like any type of coating inside an engine block whatsoever, and I'm going to do some inspecting of this one here in a little bit. And what I may just do is have machinists go ahead and bake and tumble this and knock all the coating off of it. Anything inside an engine doesn't belong there. I don't care if it's the Gliptol, any type of paint, whatever. So you need bare metal. If you know, I've built 1200 horsepower, you know, big block Ford engines. I have never had an issue with oil drain back, and guys, you know, do a lot of coatings and stuff, and under the guys that, you know, they're trying to make the oil drain back quicker. If you've ever spilled hot oil on the floor, it doesn't have any issue with covering or run hot oil down in an engine block. It doesn't have any issue with returning to the pan. So that's just my tip. Keep that stuff out of the inside of your engine. It doesn't belong there. So these come with just a hair shy of 4 1/4 bore out of the box. We're going to be going to probably a 4375 bore size. The biggest head gasket that you can get is a 4400, and that really doesn't leave a lot of room in between the cylinders. You also don't want any problems with if the fire ring happens to extend into the cylinder when, you know, it's subject to heat. That can cause areas of, you know, hot spots, and you don't want that. So it's better safe than sorry to try to, you know, keep the bores under that 4400 size. Even if you do a CNC boring procedure where the cylinders are perfectly on center with each other, the gaskets are probably not going to be. So you just try to mitigate those risks. So we're going to go for a 4375 bore size. Let's see what else we're going to do. We got plenty of room for lifter bore bushings. My goal is to use a 936 lifter and probably a keyed lifter, and I'll show those at a later date. A keyed lifter requires a special bushing that has a keyway in it that keeps the lifter from spinning. They are not held together by link bars. That makes for a very light lifter. It also puts the push rod cup a little bit further down for stability. So I've got a set of Morel keyed lifters coming, and CHE bushings that go with those. And I think we'll probably have to get into a little bit of some different lobe design for clearance when that time comes. But the bigger the lifter, the bigger generally the wheel rolling over the cam lobe, which reduces your wheel speed over the cam lobe, and also a lot more surface area to take the stress of the side loads and everything of the valve train. We're going to be running roller cam bearings. I think I mentioned that at the first. Big block Ford and EVI cams are already, if I remember correctly, around 54 millimeters. I don't know. Somebody will correct me on that. Again, I always have a ton of numbers in my head, and I don't require on my 48-year-old body my 48-year-old brain to bring those numbers back up at will and have them perfect. So roller cam bearings. The reason for the roller cam bearings, you can tell a difference with high spring loads when you turn a cam over with the needle bearings, and makes for a little. I have ran Babbitt bearings with like 1,300 pounds of spring load, and I can tell a little bit of difference when I roll the engine over. These do not require oil to them, so what happens is basically the oil would travel up through from the mains up to the cam bearing, and it's going to get deadheaded by the bearing itself. So since these function perfectly with splash oiling, then you basically keep more oil in the bottom end to the main bearings, to the rod bearings, which is good, especially if you're turning higher RPM. The judge is out, or the jury is out, on whether these make horsepower by eliminating friction. So you see all kinds of differing opinions on that, and as far as I know, I've never seen anybody do an A/B test on it. It would require a lot more variable changes, and when you get a lot of variable changes in there, you really don't know where the difference is coming from. But so even if it did just free us up 3 or 4 horsepower, then that's 3 or 4 horsepower that we didn't have. But I'm basically looking at this mainly for oil conservation, and if I can keep a lot of the oil, cloud out of the crankcase, then that'll help us free up a little bit more horsepower. Adding a roller cam bearing requires the block to be bored, and they basically bore it all out from front to back, and it requires a different cam bearing installation tool. You basically pull these in instead of knocking them in, and you have to do it in a special order. But they will bore the cam tunnel, and then I will go back, and you have to, since the bearings are not grooved, you have to take a tool and connect the dots between passages like this. This is your main oil feed, and this hole right here is what oils your distributor. So you would connect the dots here with a passage, and you would also make a passage to the front to oil your thrust plate for your cam. So a lot of work there. BBM block, I mean, it's not a bad block. I've just had a lot of issues with porosity and everything out of these blocks, and caused me quite a bit of problems. This one, I can already tell it's going to maybe give me a little bit of a trouble. I'll show you some things here to look for here in a second. I'm trying to think if there's anything else I need to show you or talk about before we go over the block itself. But let me grab my pin light and grab a distributor and show you a couple of issues that I've found with the BBM blocks in the past. All right, so I always test fit the distributors. Sometimes the holes, this relief in this china wall is not in the right spot, and the distributor hits it. We have to grind, and I've also seen some customers complain that the holes are not perfectly in line with the hole in the intake manifold, and maybe off center from like where the pump shaft goes. So you need to check that. Let me grab a pin light and I'll show you some other things. Okay, like I said, porosity is usually the biggest issue. It'll show up in a couple of different spots. One of the spots that shows up in, this is your main oil gallery that runs the length of the block, because this is a side oiler style block. Here's your number one main bearing, two, three, I'm sorry, number 2, 3, 4, and 5. So if I put a pin light in here, this is your bolt that goes to your oil filter adapter. So the first time I ran into this, had the engine on engine stand, getting ready to prime the oil pump, had my oil filter adapter bolted up, oil filter on it, full of oil, primed the pump, and this bolt started leaking. I'm like, how does that bolt leak? Well, that bolt leaks because there's a drill through and you're picking up high pressure oil right off the pump, and it's going right into that bolt. So what I usually do here, this is a 5/16 18 thread. I just coat a small short set screw with like some Indian head shellac or some silicone and run that in there. And then for this bolt, you have to run just a little bit shorter bolt. This is the only one that you have problem with. For some reason, when they drill this, they just drill just too far, and you get a nice shot of 70 or 80 pounds of oil pressure coming through that hole. I did have one block that was porous in this area. Let's see, I think this area here, and it just started, again, on the engine stand, ready to go, prime the pump, started oozing oil out of here. I was able to fix that, fortunately. Another issue is you can pretty much count on all your pipe threads being tapped just a little bit too deep. It hasn't really posed a problem for me yet. They just screw in, abnormally far, but they don't screw in too far to block, the oil passage. The same with the freeze plugs for the water. So just those things to be mindful of. Let's see, what else can we'll roll this over. We got it on an easy engine stand that I can do that. This is your feed that comes up from the cam bearing going to your cylinder head. A lot of us restrict those. BBM goes ahead and taps those for a set screw, which is nice. All right. We also have a problem with the feed holes in the saddles not matching the bearings. So they go ahead and kind of key cut those. You can tell it's not a perfect circle. Same way here. Never have any trouble out of the number 3 bearing or the number 5, but the 2s and the 4 and the 1 is usually a problem, but they go ahead and slot those. You can use either a FE bearing or a Cleveland bearing. I usually choose to run a Cleveland bearing because there's a lot more size differences in bearings that are available for the Cleveland. For instance, the aftermarket for some reason does not offer a +1 X bearing for the mains for an FE. So you have to run on a traditional FE block. If you want to run a little bit more clearance, then you can get a Cleveland bearing. You can knock the tangs off of it and do it that way, or else you're, basically taking material off the crankshaft to give you some more clearance. But we can run either bearing that we want right here. The issue here is that I've found is sometimes the tangs are not cut in the correct spots, and I've had to run tangless bearings before. I've found blocks where the main caps were on backwards and it was line bored that way. So you just kind of have to know what you're looking for and look for all the obvious problems. Some of the earlier blocks had some drill throughs back here around where the oil passage goes from this main feed. So we take a quick look at all those and make sure that we don't see any pinholes or anything like that. So just go over the block, and I've made 900 horsepower with the BBM. I don't have any qualms about going higher with it. They are very beefy. Basically, billet caps, studded, cross bolted. So it's going to be a stout platform. Here's the size difference in OD between a regular FE bearing and the roller bearing. It's really not that much. When this is the outside diameter, let me make sure my calipers are zeroed here. So if we look at the outside diameter, so 2, 3, 10. 500. So not that much difference. That'll need to be taken out of the block, but hopefully it'll give us a little bit of edge in various areas. So one other tip that I can give about these blocks is do all your machine work first before you order parts. I have seen one deck be about 25 thousandths under the other deck. So when we machine these, we put them on a BHJ fixture, which is basically a big plate that locates off the cam tunnel and off the mains, and you can measure from the center line of the crank to each deck height to make sure that you get everything squared, parallel to the crank center line, and the same dimension from end to end. And we had one of these that was really short on one side. That'll put a pretty bad hurting on your day when you've already ordered custom pistons and that sort of thing. We've also had one of these blocks with a void in the cylinder, and we had to take it out quite a bit to clear that void out. So if you're thinking that you have to have the pistons before you take the block to the machine shop, that is a big no-no. Do all your machine work first. I've mentioned this in many videos in the past. The days of having to have pistons in hand and honing the block to fit each piston are long behind us. Piston manufacturers are so good now that over 8 pistons you may vary 2 10,000ths of an inch. So don't worry about having your pistons when you take the block to the machine shop. Get all your machine work done, then start ordering your parts. Now, as far as rotating assemblies go, I'll have to wait and see what port volume and flow numbers we're dealing with the cylinder heads, and then we can make a decision on displacement. I'd rather not have to buy a $5,000 or $6,000 crankshaft if I don't have to, but we'll have to do some soul searching on stroke and rod journal diameter and horsepower to see if something like a scat shelf piece may work. Be easy to take a something like a 4250 stroke crank with the 200 rod journal and offset grind that to a small block Chevy rod journal and come up with something like a 350 stroke or something like that. So like I said, we'll just have to wait and see what the cylinder heads do, and then we can make a decision on rotating assembly. Diamond will probably get the nod for the pistons since they've already have the solid models and everything for Jay's heads, and we'll use a quality connecting rod, Carrillo or Oliver or something like that. But we'll just have to see what the heads do, and then we'll go from there. The heads are bought, the valves are on order, and as soon as all that stuff gets to the porter, then hopefully we can get some flow numbers and some port volume numbers. Alright guys, that's going to be it for this video. I hope you guys are excited as I am. I like challenges like this and specialized custom engine builds like this, so I'm going to have a lot of fun. Maybe a little bit of a slow process, especially if we have to order a crank from Brian or Winberg. Those usually run 4 or 5 months on lead time, so it could take some time, but make sure you hit that subscribe button so that you don't miss out on any updates, and put in your comment section below what you think of the build. And I hope you guys are having a good week, and I'll talk to you soon.